This is a video for working with rasters, specifically land cover and DEM. And we will be also looking at a few things within arcmap that are new. One is Arc Toolbox. We've used a little bit in the past. We're going to use much more extensively this assignment. Also take a quick look at Arc Catalog and how arcmap processes files at what I'm going to be referring to as an intermediate stage or a working stage. To get started this week, let's take a look at lore. If we look in week 5, there's an assignment process text document. That's going to be important. There's a z-factor PDF. There's the readings. There is a GIS starter list which can be accessed for your assignment this week for data. That's the last part of the assignment. The assignment PDF itself is not up in lore yet, but will come up soon. And in-class data, we'll use Sao Paulo as the example for the lab, and I'm going to go ahead and use those same files for this video. Importantly, inside that zip file is natural earth populated places, and you can either get that data here, or you can simply go to the site, which is natural earth populated places, and download the 1.46 megabyte file. Okay, so to get started on this assignment, first thing I want to do is have that text document open. That's kind of the instructions here of how to get through the assignment. So it looks very dense and intense, but we're going to work through it hopefully quickly. And I have an assignment folder set up. So in my assignment folder I have that z-factor PDF. I have assignment process file, which I have open right now. I have my populated places from natural earth. I have the land cover 2000 and also the geotopo 30. And I'm going to show you where to get these two files right now. So geotopo 30 is going to be coming from this site. This is all listed on the process sheet. It's coming from webgis.com. There's many different places to get this. This is a quick little interface. You have to be careful when you're clicking on this interface that you're getting the exact right region that you want to use, and I'll explain that in just a second. We also have the global land cover. So I'm in Sao Paulo. I'm going to be using number 1, and these frames represent the numbers down here in the list. So for South America, I would make sure that I'm downloading the Esri file. Okay, so I've already downloaded those, so I'm not going to do that right now. But these are the two sites that you would get those from. For the geotopo 30, we're going to be using this region right here. So if I click right on top of the region, it brings me to this quadrant right here. This is the one that I want. So this is slightly difficult to navigate as an interface, but once you do, it's a quick, easy download. Alright, one thing that we do have to do this week that's going to come into play when we deal with digital elevation models is we need to find out the latitude of our particular location. So we can use the B-box finder that we've used in class, or simply use arcmap and bring in populated places and go to your location and put your cursor on top, and that will give you the latitude. So I'm going to use the B-box finder real quickly, and I'm going to go straight to Sao Paulo. So I'm going to go to Brazil down here, and I'm going to notate about what my latitude is. So here it's minus 23 or 23 south. So I'm going to call that 20 to 25. I'm just going to write that down. And then what I'm going to do is go to my z-factor PDF. I'm going to open that up with Adobe Reader and just notate real quickly the fraction or the decimal expression of the conversion that needs to take place. I'll explain this when we get to it. But this is referring to the altitude, the z-factor within the DEM values. So at 20 latitude, it's 0.0000956. So I'm going to go ahead and write that down. That's all you have to do, is just write down your respective z factor for your city. To find a city, I don't want you to use Sao Paulo. We'll use another world city. There's two characteristics that I would like you to take into account. One is that it's a large city, a mega city, that has probably a lot of little satellite cities around it. And two, it has some type of elevation change in close proximity to the city itself. So I'm looking at metro extracts right now. That's listed on the process sheet. And if I take a look at these little previews, they're alphabetical, and I look at Austin, Texas, we know that's flat. I'm not seeing a lot of elevation change from the city center to its outskirts. If I look at Beijing, I can see a little bit of elevation change. Let's go down a little bit farther, see if we can find one that has a lot of elevation change. Tajikistan, this city in Tajikistan has quite a bit of elevation change to the north. That would be a good option. Dubai definitely does not. It's very flat. Honolulu actually has a fair amount of change. Islamabad, we can see the elevation to the northeast of the city. Here's Kabul, quite a bit of elevation change right there, so those would all be good options. Another way to see your city situated is to go to urban landstat images that Columbia has online. There's 3 sheets of these. And if we look at Atlanta, we can't see very much change, but if we go down to, let's say, Bogota, we can see the city itself in this kind of magenta color, and then off to the right, we can see that mountain range. That would be a very good option to use. Let's look at one more. So Kathmandu, we can see, obviously in the Himalayas, it's sitting in a valley, and right around it, there's quite a bit of elevation change, so that would be a good option also. Okay, so once I pick a city, it's large, it's a mega city, it's regional, and it has some type of elevation change, I'm ready to go. So I'm just going to go ahead and close my browser here and open up arcmap. Okay, I've already downloaded my data. So the first thing I want to do for this assignment is I need 2 files. I need the topo, and I also need populated places. We can go ahead and access that data as we have been doing, which is just simply add data through the table of contents. But I want to review one other option that will become more handy as we go along, is arccatalog. So if I click on arccatalog and I go to excuse me, the top tabs up here just right of the connect to folder, there's a toggle contents panel. And if I click on this once, it'll see what I'm currently in. If I click on it twice, it'll bring me just a directory of what it sees as options within my machine. And if I click on 3, it gives me both that view plus the actual file that I'm in, which is kind of the most useful. This dual panel is very useful. This is that ubiquitous default geodatabase. And you can see inside here a bunch of files. These are what I'm calling intermediate files or just processing files. This is when you do something in ArcGIS that is a stage along the way to getting to a final result. You know it's not the final result and you want it to go somewhere that's nice and safe and is not going to throw you errors. This is the place that you are likely to do that. Just default geodatabase. You clean it out every once in a while. Right now you can see I have a fair amount of files. I could probably clean this out, and that would be a good idea. I'm not going to right now. And then we can, of course, connect to a folder. So I can connect to my folder. I'm working in assignment 5. I say OK, and I get a nice stable connection. So I can go. It will see it under folder connections, and then I can get right in. Another very important part of arccatalog is that you can do a right click and you can go to New. And then you can create shape files, dbases, you can add new toolboxes, you can create file geodatabases, And you can also click outside a particular folder and create a new, basically a new directory. So you can create a path to a new geodatabase and work in new folders this way too. So ArcCatalog acts as a little bit more robust way to organize data and can be very useful for creating new working environments. So for my table of contents, I'm going to go ahead and add in right now my geotopo. I've renamed it from what it came down as, so the file would have been named W060S10 zip. I've unzipped it and then I renamed it geotopo30 so I know what it is. And then my LAN cover, I've changed that name so I know what that folder is. This is the file that I want, is the DEM. And we can see it has that same quadrant that was in the little interactive preview window at the website. And then I'm going to go also add in populated places. That'll be on top. Okay, these are both in World Geographic Coordinate System. You shouldn't have any projection errors at this point in time. We'll do this whole assignment in a geographic coordinate system, not a projected system. Now I want to go ahead and set up my paper. So I have these two files in here. I want this to be, I'm going to be in Sao Paulo, which is in this region right here, and you can see the coastline runs kind of east to west. Your geography may run north to south. If that's the case, then pick out a portrait, otherwise do a landscape. And we're going to go to page and print setup and do these 11 by 17. So I'm going to be 11 by 17 landscape. I say OK. I go to my layout view, and I have two options here. I can kind of just center the paper. You can also bleed it if you want to, which is bring the bounding box to a little bit to the outside and pull it all the way down to the other edge past it, and that'll give you a nice full bleed if you want to run the sheet like that. That's a possibility too. Next, I need to set up a spatial bookmark of where my final print's going to be, and you can see in my scale expression up here the map scale set to a relative scale, to 1 inch equals something. I'm going to want this to be 1 inch, right about 50 miles for this map. And we can see that it brings me into the center of the file, and I'm going to go ahead and quickly find out where my city is. So I'm going to go to Selection, Select by Attributes, and here I need to go ahead and under Name, in populated places, I'm going to pick Sao Paulo. So if I click on Get Unique Values, adds everything in, then I can go to SAOP, and it brings it right to Sao Paulo. I say Apply, OK, and it does a quick selection of my city. I'm not going to do anything with it. I just want to kind of center this map within Sao Paulo. Okay, that makes sense to me. I could put a legend down here in this blank space if I wanted to. I can see the larger region, but I can also see my city. My city's centered. This is probably good. You may want to go to 1 inch equals 40 miles. It's kind of up to you, the scale. It shouldn't be much more than 50 miles, I don't think. So we're going to go ahead and create a bookmark right now. So I'm going to call this map 1. And I can always now get back to this particular location, and this exact frame will always be set up for me. I'm going to save the file right now, so I go to Save As, and I'm going to save it in my assignment 5. I'm connected to it. It goes right to it. I'm going to call this assignment 5, and then the last name, my last name, Metz, and say Save. Okay. I'm ready to go ahead and get start working. Importantly, I need to take off that selection. Select and clear the selected feature. Alright, what we want to do now is we have all these values within this particular file, within this DEM. So if I click off populated places and I take my little information tool, I'm going to get back into data view, and I start clicking around my file, we can see that my pixel value is 881 in that particular location, and then if I come down here, it's going to be 222. If I come out here, it's going to be no data. So I can go all around this particular DEM file, and pixel value is giving me a different expression each time, and that's basically the change in elevation based on meters. So what I would really like to do here is I would like to have that particular meter. Okay, let's zoom into one of these cities. Get real close to it. And if I click on it right outside of the field, I can see that the pixel value is 650 there, 650, 650, 650. So everywhere around here, I'm probably sitting in 1 pixel actually. I would like to have, for this feature here, which is a city, I would like to have that value sitting in the attribute table so I could label it that particular elevation. And that's what we're going to do now. So we're going to create a conversation between our pixel values, our raster values, and the actual shape file or the vector feature. I'm going to zoom back out, zoom to layer. And before I do that, I want to, this is kind of this gray blob. We can't really tell the difference between these, between the values. So I'm going to go down to properties, and I can go ahead and put on a different ramp, and that would simply make the color different. That doesn't do a whole lot for us. But one thing we can do is we can click on unique values and create what's called an attribute table. We know those. And say OK. And then if I go down here, I can open up the attribute table, and it actually sees its values and counts. And then once I have the attribute table, then I can go back to properties and go into a classified system. Right, remember we were classifying vector data based on thematic maps. And now I can go ahead and put in a color ramp that's going to make a little bit more sense. So there's a couple of these that work for elevation. They're about 1/3 of the way down. The first one has these browns and real vibrant yellows in the middle, and then there's another one right underneath it that's a little less intense. Let's try that one and say apply OK. Those two are pretty good for elevation. So basically the blue areas now are the lower elevations, and the higher elevations are these purples, and of course the whites at the very top. So that gives us a little bit better sense of the elevation of the file. So let's go ahead and start our process. So the first thing we want to do is we want to use our Arc Toolbox to do this. So we're going to go to Arc Toolbox, and we basically need to create an extraction. So we're going to extract from the DEM into the points. And under the assignment process sheet, that is number 6. So extract raster values, elevations to points. So we're going to use the Arc Toolbox, Spatial Analyst tools, and we're going to extract values to points, and we're going to save that in the geodatabase file. So I go down to Spatial Analyst tools, and then I'm going to click on extraction, and I'm going to extract values to points. So the input features is going to be our populated places. That's a feature. And our input raster is going to be the DEM. Click on that, and then it's going to set up the default geodatabase path, and it's going to name it extract shape 3, and it'll bring it into my table of contents when it processes the file. So I'll say OK. I'm not going to click on any of the options. Okay, so it produced a new file now. So if I go ahead and open up that shape file, I can see that I have 7,343 records, and at the end here, down at the end, I have raster values now. And if I sort these ascending, it's going to show me a bunch of -9999. That's a kind of a null value. That's a nothing value. That's where it's basically, when it makes the join, it finds no correspondence. So if we were to go down in raster values down to the bottom here, we can see we actually have real numbers down here. If we go ahead and highlight one of these as a selection, we're going to see that selection somewhere within our DEM extent, the overlay. Okay, so those are the points that we really want. We don't want all this stuff that's sitting on the outside, because that really has that elevation value of -9999. So the way to do this is we're going to go into the attribute table and we're going to do a selection now. I need to make sure that I clear out that particular selection that I just made. Okay, and this is, we're going to be at number 7 now. So we're going to select by attributes with the extraction, and the roster value is going to be that -999. I'm going to copy this expression, and then I'm going to drop it in, select by attributes. Now I need to make sure that I'm selecting on the right file. That's that first one, extract shapefile 3. And I can just drop this expression in and say apply. It picks out 6,991 files. I say OK. And then what I'm going to do, it's got all these things selected on the outside that I don't want, but what I really want is what's on the inside. To do that, I can go to switch selection, and that selects everything on the inside. This is what I want. Now what I'm going to do is I'm going to extract this out, data, export data. It's not going to go to the default geodatabase at this point. This is a file that I actually find valuable and I want. I want to keep it. It's not an intermediate file. And I'm going to go to assignment 5, and I'm going to call this I'm going to call this maps data. You can call it whatever you want. It's basically your export folder. In here, I'm going to make sure it's a shapefile, and I'm going to export it as, I titled it here. We want to call it pop place evaluate or elevation. I called it eval. I should be calling it elevation. ELVA. Is that right? Elevation. So I'm going to call it ELEV. Pop place eval. Eval. Excuse me. Okay, so I'm going to go ahead and copy that in and say save. Okay, and then I'm going to export to my map. Now if I take everything away, I have these points, and if I open the attribute table now, I can see at the end I have a roster value. And that's the actual Geotopo 30 elevation at that particular location within Natural Earth, that particular cell. Now what I want to do is I want to do a quick comparison between something that's already in Natural Earth, which is their recording of Geotopo 30, and you can see it right here. Okay? And they've gone through a process to get those Geotopo values on their own, and I think it may have been some type of interpolation that's not picking the exact point, because if we move ours over, our selection, we'll see some cases where it's exactly the same and other cases where it's not. So I'm just going to put that column right next to it, and we can see a lot of these are different. So the first one, they're seeing it being an elevation of 28, we're seeing it as 1. This one shows exactly 63, 63, 17, 17. This one's 54 versus 50, so it's 4 meters off. So you can see, depending on how you actually do your GIS work, you may get different values depending on, especially with elevation. Because what our process was to pick the exact grid, the cell, or the exact cell location, and extract that value out into the point. So it was a very specific extraction method. There was no interpolation going on. Okay. So now what we want to do is we want to have a label. What we want to, our ultimate goal here is to have the name of the city and then have the elevation as an expression right behind it. So we're going to go ahead and set that up now. Okay, so I want to go ahead and remove populated places. I'm going to remove extract shapefile. And these are the two files that I want to be working with here on out. So I'm going to go ahead and save the MXD at this point. Okay, so I've updated my MXD. It's nice and simple. And we want to go ahead and set up a label instance now. So I'm going to go down to Properties and go to Labels. And under Labels, I can actually create an expression here. So I'm going to label all features in this layer the same way. I'm going to go to Expression, and here I'm going to go ahead and I think this is point number 9. I'm going to take that expression from 9. You could either do the Geotopo 30 from Natural Earth, or you can do your raster values calculated. And then you want to verify this expression. You can see in the bottom the sample label, it doesn't show up. If that's the case, change the parser to either JavaScript or Python. Okay, it shows it as just the name on Python. Let's try JavaScript. It's showing it just as the name there, so it's not pick. Whoop. Let me go back and put that in. So I'm going to verify. There it goes. So here it shows the name of the city and then the elevation right after it. That's kind of what I'm looking for. Okay, we'll stick with the Python parser. That's okay. Okay, so I say OK. Make sure that label features in this layer is on. Apply it and say OK. And then when we get to our region here, we have a simple label that shows the name of the city plus the elevation. One thing that I don't like is that there's no space in between the two, so I'm going to go ahead and go back and create a space real quickly. To create that space, what I can do is I can just go ahead and put in 2 quotation marks and nothing in between those quotation marks, and that's a way to do it. So it could be this expression right here. I might paste that into the assignment process text as an option for you. That gives a little bit more space between the name and the actual number. Okay, so say apply, okay. Now I'm going to go, to finish up this map, we have the actual data organized the way that we want it to be. So I'm going to go ahead and do a file save. And it's kind of a flat map right now. So what we're going to do is we're going to do what's called a hillshade. And I'm going to keep the values currently for my legend. I'm going to go into the classes under properties, and I want to clean up those for the legend. So under symbology, under my label, instead of being 340.00001, I just want that to be 340. There's a couple ways to do labels. Some people go 1 to 340 and then 340.01 to 671. I kind of like keeping it really simple. Most people realize that the next class up is whatever number it is, 0.001. So you can usually, there's a couple ways to do it, but this is a pretty standard style. It's just 1 to 340 and then 340 to 671, 671 to 971. Okay, remember these classes are breaking based on natural breaks. You could certainly have a different classification system if you want to. Say apply, okay. Then when I drop this in as a legend, it's nice and clean. In values, I would change to be meters. And I might call the title elevation, something like that. Okay, I'm going to go ahead and file save that. For your final map, I do want to see your legend have only the classification scheme for the DEM. Alright, so we have this set up right now. We're going to do a copy of this file. We're not going to actually copy the whole file itself. We're only going to copy it in the working instance of the MXD. So we're going to do a copy and then a paste within the table of contents. So I do a copy and then I go up to layers and do a paste layer. Okay. Now this is the file that on the very bottom that I'm going to change into hillside. So I go to Arc Toolbox, and I'm going to go down to Spatial Analyst Tools. If your Spatial Analyst tools are not working, you need to go up to Customize and go to Extensions and make sure it's clicked on here in Extensions. So mine's working. Now we're going to go down to Spatial Analyst and we're doing Surface Tools. So that's down here at the bottom, and Hillshade is what we want. We're going to input the raster. That's going to be the bottom one, not the top one. And it's going to output to the default geodatabase. That's fine. The azimuth and the altitude is kind of the way that the appearance of the hillshade is organized. So we can change kind of the direction and the location of the sun, the fictitious sun, when modeling our hillshade. So this is the point where it's critical to enter in the correct z-factor, or a correct, or close to a correct z-factor. That's all based on the z-factor sheet, and it has those decimal fractions there that we can put in for our particular location. So we were at about 20° latitude south for Sao Paulo, and that number was 0.00000956, not 1. The default is 1, and you're only going to use 1 when you're actually in a projected coordinate system. In this case, we're sticking with a geographic coordinate system, so we have to put in a z-factor. And what the z-factor is doing is that it's saying, for this particular latitude and longitude location, I have to correct that value in the DEM, the cell value for elevation, so that it works correctly for the hillshade appearance. It can't be a direct one-to-one. I say OK. It'll take a second to process this. Okay, so it produces the hillshade, and this is kind of what the hillshade looks like. This one seems slightly murky to me. I might try a slightly different fraction there to bump the z-value up just a little bit. Remember, hillshades are an appearance base layer. They're not used for analysis. They would be used in a reference map. We're producing somewhat of a reference map just based on elevation. And they sit at the very bottom of a stack. So I'm going to go ahead and bring that down here to the bottom. And I'm going to get rid of that last instance of elevation. I'm going to remove that. So I basically have my hillshade and my elevation sitting here. In your legend, you should not be showing the hillshade as something, as an item being added to the legend, because it doesn't really have any bearing on the map use at all. It's just an appearance layer. Now we have this elevation sitting on top of it right now, so what we want to do is we want to go ahead and make that, under properties, somewhat transparent, and 40% should work pretty good for us. So I go under display, under layer properties, right click to layer properties, display, and for transparency I'm going to put in 40% and say apply OK. And you can see that it gives it a little bit of a dimension to it. I might make that actually a little bit more transparent. Maybe try 50%. Okay, that shows up pretty well. And then what I'm going to do is I'm going to go to my layout view, and then I'm going to go to bookmarks, to my map 1, make sure it's all centered the way that I want it. And this is kind of what my map would look like. That seems a little too busy to me, so I'm going to go ahead and make 1 inch equals 40 miles and see how that looks. Actually, I'm going to even go to 30 miles. Okay, this is pretty good. So it's going to show me Sao Paulo, and it's going to show me all these cities around Sao Paulo, their elevation. So I can kind of get a quick sense of the terrain, and then also the elevation for each one of these cities. What we can do if we want to is we can change that symbol around. So you might want to have the color be no color, but have an outline for the feature. Something like this might work. Okay, so you go ahead and symbolize the way that you are getting comfortable with symbolizing points features, however you want to do it. So this is going to be the first map that you turn in. So you're going to have an elevation, and you're also going to have a hillshade. We're going to have done that process with our toolbox, that analysis and extraction process for population, getting that into the attribute table. And importantly, we're going to insert a legend. I'm not going to spend a lot of time with a legend designing it right now. All I want, though, is just the elevation in the map. Okay, so it would look something like this. I would continue on and make this map a little bit better. You can try the full bleed and see if you like that, see what it looks like on the other end in Acrobat Reader. You can always skip that and bring the frame within the bounding box in a more traditional manner also. Okay, so that's it for the first part of this assignment. I'm going to go ahead and stop the video now and do a second one for the second part of the assignment.